what is electric current? So flow of electrons in a conductor. Flow of electrons in a conductor. Okay. So let us assume that the analogy for this flow of electrons is water flow from a overhead tank. This is an overhead tank. You are in the ground floor. You are in the ground floor. You are having a tap. You are having a tap. This is the tap at your wash basin. Am I correct or not? This is overhead tank. Why you are keeping the tank at first floor or second floor? Suppose you are happen to be at ground floor, means that the tank is in the first floor or second floor. Why? To get potential energy is converted into kinetic energy. That's why you are getting flow rate. So a pressure is required. So indirectly, if we can talk in this way. So because of this height, there is a pressure difference between this point and this point. Let us assume that the pressure here is 0. Here, atmospheric pressure. The pressure here is atmospheric pressure. Here, the pressure is mgh. mgh. Mass, gravity, and height. So, mass and that's what I am saying. You are repeating. So, because of that, some pressure is developed here between these 2 points, between the point 1 and 2. There is a pressure difference. That's why there is a flow rate. You can notice that as the level in the tank decreases, you can notice that there will be a flow rate in the tap is reduced. Have you noticed that? In a solo, tank is going to become empty. That's why the flow rate is less. The pressure is reduced because the height of this building is say h, means this water tank height is about h, means initially total height is h plus h. As level decreases, this h decreases. That's why level also decreases. That's why pressure decreases. So flow rate decreases. So pressure difference between the 2 points, that is point 1 and 2, is important to get flow rate. Like that, in a electric current, potential difference is, this is analogous, identical. Pressure difference is required. Pressure difference is, potential difference is required for a flow rate of current. Okay, so in a electric current, how the circuit looks like? A battery will be there. What is this? A battery, a DC battery. Battery means DC only. A battery is there, say 5 volt. Here you are having one resistance of 5 ohm. Resistance is there. So here, this battery develops a pressure across this resistance. This resistance is like your tap. The resistance is, because the tap, if you open completely, the flow rate is maximum. If you close partially, flow rate decreases. If you fully closed, it becomes insulator. No flow rate of water. If you completely closed, means no flow rate. You understand this? So this is like a resistance. So if resistance increases, flow rate decreases. So this is like this 5 ohm resistance. The tap is like this 5 ohm resistance. You have to imagine like that. Because you cannot see the flow of electrons. That's why we have to imagine like that. But you can see the water flow rate. So this 5 ohm, the pressure, potential difference is 5 volt. That's why current through this is, I can say 1 ampere. How I got? By Ohm's law. What Ohm's law says? V is at constant temperature. You should not forget that word. The constant at constant temperature. At constant temperature. At constant temperature. Yes. At constant temperature. The voltage, the potential difference across any 2 points is directly proportional to current through it. That is Ohm's law. Don't tell. If I ask you, tell. Otherwise, that also will be recorded here. So your okay, no problem. You can tell. If I didn't record, you can talk. I am recording. If I ask you, tell. Otherwise, don't tell. So 5 ohm resistance, 5 volt. That's why 1 ampere, because of Ohm's law. Ohm's law says V is directly proportional to I. Ohm's law says V is directly proportional to I at constant temperature. That is very important. Or V equal to Ri, where R is the constant of proportionality, or V by I equal to R. V by I equal to R. We can say in the other words, Ohm's law, the ratio of potential difference and the current through them is a constant at constant temperature. The constant temperature is very important. So V by I equal to R. So we can say the Ohm's law is V is directly proportional to I at constant temperature. So Ohm's law is very, very important to find the current through it. So how to, this is not analogy to this. To understand the pressure difference, I am telling this circuit. But this is not analogy. I can put the analogical circuit, mechanical circuit, that is water flow circuit for this. That is this way. Do you know that what is the function of pump? You are having pump, your home, no? You will pump the water from sump to overhead tank. So what is the function of it? It develops a pressure difference across 2 points. One is input, another one is output. It develops a pressure because a centrifugal fan is rotating. That's why low pressure is developed. That's why water is flowing from this side to that side. That is pumped to the overhead tank. So it develops a potential difference, pressure difference. So like that, I can put a circuit like this. So I can put, this is the pump. This is the pump. So I can put a fan. It is rotating. It is rotating. Suppose this is rotating this way, means negative pressure will be developed this side. That's why water in the bottom side will go upside. Am I correct or not? So here I am putting one hand valve. This is the hand valve. This is symbol for hand valve. That's why I am using that. I am connecting this way. Assume that the tube is filled with water. Assume that the tube is filled with water. If you turn on this pump, this is the pump. This is the pump. If you turn on the pump, it will rotate and it develops a negative pressure here. That's why the water in the bottom side will go to the point 2. Am I correct or not? That's why it will displace adjacent water. That's why there is a circulation of water from this side to this side. Am I correct or not? Till you stop this pump, there is a flow of water. This is identical to this circuit. This is identical to this circuit. Let us assume that initially this hand valve is completely open, no resistance at all. That's why the pump pumps at 5 liters per second or 5 liters per hour. Let us assume it pumps at the rate of 5 liters per hour. 5 liters per hour. I am closing this valve gradually. 50% I closed. What will happen? Now it is reduced to 2.5 liters per hour because the resistance is increased. The resistance to the flow of water is increased. That's why there is reduction in flow rate of water. You understand that? That way, this resistance resists the flow of current. Resist the flow of current, like this hand valve. If you completely close this hand valve, what will happen? Even though the pump is pumping, there is no flow of water because the valve is completely closed. Then it becomes insulator. Instead of resistor, if you put insulator here, there is no current flow rate. If it is in conductor, then there will be a flow of current. Resistor is conductor or not? Yes or no? Yes, resistor is a conductor, but it resists. It resists. I am saying that you must come. 11 o'clock means you may resist, but you have to obey. No other go. You may resist, but you have to obey. You should come in time. Like that, it resists the flow of current, but it has to obey. No other go. But because of resistance, there will be a flow rate may vary. Flow rate may vary. This conductor also having some resistance. This conductor also, this line is conductor. You said there is no drop we are assuming while solving the sum. But it also has some resistance. We are ignoring it. Suppose I am having 1 lakh rupees and 10 paise. What I will say? I have 1 lakh 10 paise or 1 lakh. 1 lakh only. Like that, the resistance in the conductor is negligible. That's why we are not talking about it. It is, we are ignoring that. I understand this point. Suppose I am having 55 paise. Suddenly I found another 10 paise. What I will say? 55 paise or 65 paise? 65 paise. Because then it becomes considerable amount. We'll compare with 55 paise, 10 paise is considerable amount. That's why I'll say 65 paise. Like that, if the resistance is negligible, this 5 ohm becomes very small, very, very small. Then the conductor resistance also comes into play. Do you understand this? So for 5 ohm, it is negligible. For 5 ohm, it is negligible. So every metal has some resistance. But we'll compare with usable part, it is negligible. We'll compare with the usable part, it is negligible. While calculating, we are ignore that and we are calculating. So every point has some resistance. Here also, not only this hand wall gives resistance, this path also giving resistance. You might have know that if you put so many turning points, the flow rate will decrease because resistance will be more. You understand that? So this path, this tube also having resistance, but negligible while compare with that hand wall. Like that, this conductor also has resistance, but it is negligible while compare with that resistance. By Ohm's law, we can find the current. What is the formula now? You can manipulate this V by I equal to R. That is V by R equal to I. V is 5 volt. That is potential difference is 5. Resistance is 5. That's why current equal to 1 ampere. Current equal to 1 ampere. So this is analogy for electrical circuit. Why I am saying this as analogy? Here, this over tank water is going to ground floor, but it is not again coming to the tank. But in electric current, the flow of electrons, you cannot tap these electrons here. You cannot tap. It should go again there because you cannot change the number of electrons in any metal. You cannot change. But you can force the electron to flow and again it has to come. You cannot take away. You cannot take away. That's why this is identical to electric circuit, not this. Not this. This second circuit is identical to electric circuit, not this, not this. This is identical to electrical circuit because you cannot take away the electrons. It should come again where it is started. It should come again where it is started. Because in a copper, how many electrons are there? 29 electrons are there. You cannot change that. If you change that, what will happen? It never be a copper. So you cannot change. But you can force for some time to flow. You can force it for some time to flow. But again, it has to come. If some electrons leaves from here, some electrons should come and occupy that place. That is possible. You cannot take away. You cannot remove. You cannot remove. That's why a closed path is required. That's why it is called closed circuit. If circuit is closed, it is against our conventional English. Gate is closed means what? You cannot enter. Am I correct or not? Circuit is closed means what? Electrons can enter. So it is not conventional English. I understand this. So circuit is closed means if closed, then only electrons will go to the starting point. Do you understand this point? That's why the second circuit is analogy for electric circuit, not the first one. Not the first one. Anyhow, the pump is identical to battery. The pump is identical to generator, not battery. I will understand later. Okay, anyhow, you can assume, at present you can assume it is like battery. At present you can assume it as a like battery. Okay. Two resistances are in parallel. That's why current through this is I1 and current through this is I2. Let us assume that total current is I. The potential applied is V. This is identical to this circuit. This is the pump. This is identical to this. Two hand walls are there. One is V1, another one is V2. The flow rate through this valve is Q1. Flow rate through this valve is Q2. Total flow rate is Q. This we can imagine. Total water flow rate is Q. So many 10 liters per hour. So suppose the total liquid flow rate because of this pump is 10 liters per hour. Let us assume that through this valve 1, 6 liters per hour means 6 liters per hour means definitely what is the flow rate through this? 4 liters. 4 liters per hour. This is obvious. The same here. If you know the total current, suppose total current is 5 ampere. Current through the first part is 3 ampere means definitely what is the current through this? 2 ampere, because these two are in parallel. Another one is already we have seen that this pump is developing a pressure difference across these two ends. Between 1 and 2, it develops a pressure difference. That's why there is a flow rate. Flow rate is like this, through this, again through this, again through this, and all are collected and coming here. Now, the pressure at this point, let us assume that there is no pressure drop up to this point because there is no resistance. We are assuming that the pipe is ideal pipe. There is no resistance in the pipe. That's why there is no pressure drop. The pressure at this point is maintained up to this point. So pressure here is say P means here also the pressure is P. Here also the pressure is P. Am I correct or not? Because let us call this point as A, this point as B. Both A and B, there is no resistance. Between A and B, there is no resistance. Only tube. And it has no resistance. That's why there is no pressure drop. So suppose the pressure P is here means here also P, here also P. Here the pressure is 0 means here also 0, here also 0. That's why pressure across this valve is P. Pressure across this is P. In the same way, here the applied voltage is, applied voltage is V means the voltage across the resistance R1 is V as well as the voltage across R2 also V. That's why in the parallel circuit, this is analogy for electric circuit. This is the pump system analogy to this electrical circuit. Here, both the valve experience the same pressure. In the same way here, both the resistance are experiencing the same voltage drop. Same voltage drop across two resistance. So this is analogy for parallel circuit. Suppose I am having another circuit. This is looking like this. one resistance, another resistance. They are connected in series. Both resistances are connected in series. Applied voltage is V. For this, the pump system is this. One hand valve, another hand valve, another hand valve, V1 and V2. Again, it is connected here. This is identical to this, the analogy to this circuit, electrical circuit. Here, the pressure developed by this pump is P. Here, one resistance, that's why partial pressure is dropped. P1, the pressure is dropped here. That's why pressure is reduced while reaching V2. That pressure is P minus P1, that is P2. Say P2. Definitely pressure will be different, not equal. Here, if you apply a voltage of V means, the voltage drop across R1 is V1. The voltage drop across V2, R2 is V2. You know that, suppose both valves are completely open. Let us assume that now the total flow rate is 10 liters per hour. So both valves are completely open, 10 liters per hour. Suppose I am closing V2 partially. What will happen? Flow rate is reduced to 5 liters per hour. What is the flow rate through V1? What is the flow rate through V1? I am not touching V1. I modified V2. I closed V2 partially. Because of that, flow rate is reduced from 10 liters per hour to 5 liters per hour. What is the flow rate through V1? Say, oh, the remaining 5 liters, where it will go? Remaining 5 liters, where will go? Both valves will have equal flow rate. There 10 liters per hour is reduced, total flow rate is reduced to 5 liters per hour. 5 liters per hour. 5 liters per hour. Because I closed V2 partially, that's why flow rate is reduced means flow rate through V1 also reduced. I understand that. Flow rate is identical to current. Water flow rate is identical to current. If suppose both valves are completely open, I am partially closing V1. Resistance is increased. That's why flow rate is reduced to 5 liters per hour. Means what is the flow rate through V2? 5 liters per hour. In the same way, suppose the total current is 2 ampere means current through R1 is 2 ampere, current through R2 also 2 ampere only. To understand that, I am explaining this. To understand that if they are in series, two valves are in series, flow rate in first valve as well as flow rate in second valve are equal. This is, you can easily imagine. So current will be equal if they are in series. Voltage drop across them will be different. What is voltage drop? What is applied voltage? The battery is developing some pressure. Like pump develops some pressure means, like that, it develops some pressure. Part of pressure is dropped here and the remaining pressure is dropped here. Now it becomes 0. Here itself it becomes 0. After P2 it becomes 0. In the same way, you are applying say 5 volt. Applying 5 volt. 3 volt is dropped across V1. 3 volt is dropped across V1 means, what is the voltage drop across R2? Definitely 2 volt. At this point, the voltage becomes 0. What is the voltage at this point? What is the voltage at this point? 2. Voltage at this point is 2. What is the voltage at this point? What is the voltage at A? 5 volt. 5 volt. There is no drop. Here it is 5 volt. 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 Up to this point, up to A, it is 5 volt only. No drop at all. Because it is conductor. Ideal conductor. While calculating, we are thinking that the conductor doesn't drop any voltage. So up to A, it is 5 volt only. At B, what is the voltage? 3 volt is dropped across R1. That's why at point B, what is the voltage? 2 volt. The 2 volt is dropped across R2. That's why at point C, what is the voltage? 0 volt. I think now you understand. So in series circuit, voltage will be gradually fall. In a parallel circuit, voltage will be equal, but current will be different. So you have to imagine like this. Voltage is like pressure in a water circuit. Current is like flow rate, liquid flow rate. Liquid flow rate. So now coulombs per second current is. So it is flow rate. How many liters per hour with respect to time we have to tell. So they are identical. They are identical. I think you understand both. If these two are in parallel, these two are in series. Suppose I'm having, I think any doubt in this part? No doubt. So in a series circuit, current will be equal. Voltage drop will be different. In a parallel circuit, voltage will be equal, current will be different. Now, this is R1, this is R2, applied voltage is V. I am finding an equivalent circuit that gives the same amount of current, total current. That resistance is called R equivalent. I am replacing R1, R2 by R equivalent. Suppose current through this is 2 ampere means here also 2 ampere, same current. Here I am giving 5 volt means here also 5 volt I am giving. For that it gives 2 ampere total current, here also 2 ampere. That's why this resistance is called R equivalent of parallel combination of R1 and R2. R equivalent is parallel combination of R equivalent is equal to parallel combination of R1 and R2. How to find that? What is current through this? I1. Am I correct or not? What is current through this? I2. What is total current? I. So I can write I equal to I1 plus I2. By Ohm's law, how I can write I1? But it is parallel circuit. There is no V1, V2. V only. The parallel circuit, that's why voltages are equal. That's why I can write V by R1 plus V by R2. That is equal to I. Or I can say V multiplied by 1 by R1 plus 1 by R2. I equal to. Let it be 1. I said it is equivalent circuit. That's why this I equal to V divided by R equivalent. Am I correct or not? Here also same current. Current is equal. That current is equal to V by R equivalent. Am I correct or not? Because this resistance is equal to R1, R2. This is 2. From 1 and 2, both currents are equal because both circuits are similar. That's why similar effect. That's why I can equate 1 and 2. Therefore, V multiplied by 1 by R1 plus 1 by R2 equal to V by R equivalent. V getting cancelled. Therefore, 1 by R1 plus 1 by R2 equal to 1 by R equivalent. If you want to find R equivalent means we have to take inverse of R1 and R2, add, then find again inverse. In Calc, up to how to operate this. But you might have studied like this, R1, R2. If you take LCM, then you will get R2 plus R1 equal to 1 by R equivalent. This implies R equivalent equal to R1 R2 divided by R1 plus R2. Am I correct or no? Instead of doing like this, you can quickly, you can stop here and you can find the R equivalent directly. If you use calci, how to operate? Press R1. Suppose 5, R1 equal to 5, R1 equal to 5, R2 also equal to 5. Press 5 first. Inverse, X inverse. What you will get there? 1 by 5 plus. Again press 5. Press X inverse. What you will get there? 1 by 5. If you press equal to, what you will get there? 1 by 5 plus 1 by 5. Sum you will get there. Now again you got 1 by something you got. Now you press X, again X inverse, what you will get? R equivalent you will get. You understand this? You can, any number of resistance in parallel means, in calci, what you have to do is, that number X inverse, plus that number R1 X inverse, plus R2 X inverse, plus R3 X inverse. Finally, you have to press equal to. Equal to, if you press, you will get 1 by something you will get. So again, the answer, once you got the answer, again press X inverse equal to. X inverse, again you have to press equal. If you press equal to, what you will get? R equivalent you will get. No need to use this formula and all. I understand this. Therefore, in a calci, R equivalent equal to R1 plus the value. R1 means value, X inverse plus, press X inverse plus R2 X inverse. Then press equal. You will get something. Say X. X you got. Again, this is answer. Sorry. This is answer. If you press equal to, you will get answer. Again, you have to press X inverse. Again, equal to. You will get the R equivalent. Any number of resistances. Suppose you are having 5, quickly you can calculate by using R equivalent. Suppose there are 3 resistances. What is the R equivalent? R equivalent equal to 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. No need to simplify. You write this formula and directly you write R equivalent. You can find directly. Suppose in the another circuit, what I am having is 2 resistances are in series. 2 resistances are in series. The applied voltage is V. Here the resistance is R1 and this is R2. We know that potential drop across R1 is V1, potential drop across R2 is V2, because it is series circuit. Current is equal, but voltage is different. That's why here the potential drop is V1, here the potential drop is V2. The total drop is V. Therefore, we can write V equal to V1 plus V2. By Ohm's law, V1 equal to what? Current is I, because series circuit. Therefore, I R1 plus I R2, V equal to. That is equal to I multiplied by R1 plus R2. Let it be 1. Suppose I am finding an equivalent circuit that gives the same effect, but instead of 2 resistances, I am using only 1 resistance, R equivalent. What you will get? What is the current I? The voltage is, applied voltage is V. Current through this is I. R equivalent. Therefore, V equal to what? I multiplied by R equivalent. R equivalent. Let it be 2. Let it be 2. From 1 and 2, we can equate right hand side. Therefore, I multiplied by R1 plus R2 equal to I R equivalent. I getting cancelled. Therefore, R1 plus R2 equal to R equivalent. This circuit also having the same amount of current. That's why it is R equivalent. Suppose 3 resistances are there, we have to add. That's all. Again, we will come here. Here, 10 liters per hour is flowing through that. Here, 6 liters per hour. Here, What is the flow rate? 4 liters per hour. This is the junction. What is the incoming flow rate? 10 liters per hour. Outgoing flow rate? 4 liters and 6 liters. This is called Kirchhoff's current law. Kirchhoff's current law says algebraic sum of total current at any junction equal to 0. But current is entering means we have to assume positive. Current leaving means you have to assume negative. Here, 10 is positive because it is entering. Minus 6 minus 4. Sum is equal to 0. That is Kirchhoff's current law. Algebraic sum of total current at any junction equal to 0. Here, consider this junction. What is current leaving? 10 liters per hour. Am I correct or not? What is current coming here? 6 liters per hour. What is the water coming here? 4 liters per hour. So, minus 10 plus 6 plus 4 equal to again 0. So, Kirchhoff's current law. So, algebraic sum of total current at any junction equal to 0. So, suppose you are considering this junction means I is plus incoming current. I1 is outgoing current, minus I1, minus I2 equal to 0. This is Kirchhoff's current law. Any unknown is there, substitute in this equation and find. That's all. You know Ohm's law. By Ohm's law, we can write expression for, suppose I am having a sum like this. Here, this V is unknown. This current is known, 5 ampere. This resistance is 3 ohm. And this resistance is 2 ohm. 2 ohm. Let us assume that here 5 2 by 3 ohm, 2 by 5 2 times. So 2 ampere, here 3 ampere. So what you will get? What is the voltage? What is the voltage? The voltage is not given. Can you find? How? 6 volt. Am I correct? 6 volt. Am I correct or not? We can find. So suppose this resistance is not given. So it is R2. Sum is given like that. How to find? We know that this is I minus I1 minus I2 equal to 0. I equal to 5 ampere minus I1 equal to what? It is given, not 2 ampere is not given, 5 ampere only given. 5 ampere is given, R2 is not given, 6 volt is given. 6 by 3. I1 is 6 by 3. And here minus 6 by R2 equal to 0. Can you find R2? Yes. That's all. So we can find R2 from this equation. From this equation, we can find R2. Check whether you got 2 or not. You will definitely get 2 ohm, no other go. So R2 equal to 2 ohm. So like that, they will coin some sums, that's all. But anyhow, what and all we used here? We used Ohm's law as well as Kirchhoff's current law. That's all. Suppose you are, have you got this point? Got 2 ohm? Okay. The V is called the electromotive force, EMF. The V1, V2 are called the potential drop because spending something, the potential is dropped across resistance. That's why it is called the potential drop. V1 and V2 are called potential drop. Huh? Yeah, V1 and V2 are called potential drops. V is called EMF, electromotive force. What is V equal to what? What we wrote here? V equal to V1 plus V2, or we can write V minus V1 minus V2 equal to 0. Algebraic sum of EMF and potential drop equal to 0. That is Kirchhoff's voltage law. Potential drop expenditure, that's why it is negative. EMF, it is positive. So wherever it is generated something, it is positive. So V minus V1 minus V2 equal to 0. Algebraic means it has sign. Algebraic sum of. Otherwise, we can write sum of. Why we are not write sum of? Why we are not writing sum of? It has some sign, positive or negative. That's why algebraic sum of what EMF and potential drop equal to 0. That is Kirchhoff's voltage law. Kirchhoff's voltage law. 5 volt, 2 resistances, 3 ohm, 3 ohm. What is the current? Total current. Find the total current. What is 5 by 6? 5 by 6, how much? 0.83 ampere. That is answer. Suppose 2 resistances are in parallel. The same 2 resistances are in parallel. Same 5 volt. 3 ohm, 3 ohm. What is the equivalent resistance? 1.5. Always we should remember that if the 2 resistances are equal, equivalent resistance is half of that. So 1.5. 5 divided by 1.5. How much? Huh? 3.33. You notice that if the 2 resistances are connected in series, same resistance, same voltage. If the 2 resistances are connected in series, what is the current? 0.83 amperes. If the 2 resistances are connected in parallel, current how much? 3.3. So it means what? R equivalent of parallel circuit will be less. R equivalent of parallel circuit will be less. If resistance decreases, current will increase. Resistance decreases, current will increase. I equal to what? V by R. Current equal to what? V by R. R equivalent decreases means I will increase. So parallel means R equivalent will decrease. That's why current increases. Series means current decreases. These are all concepts we should remember. So if we put 2 resistances are in series, current will decrease. The same 2 resistances, if you put in parallel, current will increase. Suppose I am having this way. What is total current is 3.33. Come to this first. What is current through this? What is current through this? 3.33 divided by 2, how much? Equal resistance, therefore equal current, how much? 1.66. Am I correct? Am I correct or not? So equal current in both branches. Suppose I am having like this. 3 ohm, 2 ohm, 5 volt. What is the current through each branch? What is equivalent resistance? Find equivalent resistance first. As I said, find R 1 by R equivalent equal to 1 by R equal to 1 by 3 plus 1 by 2. Therefore, R equivalent directly you can write by using calci. Bring calci from next class onwards. If you didn't bring calci, you will not be allowed inside. 1.2 resistance equal to 1.2 ohm. Therefore, what is total current? I equal to 5 divided by 1.2 equal to how much? 4.16 amperes total current. What is current through 3 ohm? Current through 2 ohm? Here you know voltage, that's why you can directly find 5 by 3. That is current through 3 ohm. 5 by 2, 2.5 ampere through this. You can find 2.5 ampere through this. What is the remaining current? 1.16 ampere through 3 ohm. 1.6, then the answer is wrong. 2. Yes, 1.6. Yes, 1.6. Yes, correct. You are correct. So first branch, the current is 1.6 ampere. The second branch current is 2.5 ampere. Am I correct or not? Resistance is less means more current. Resistance higher means less current. These are all we have to notice. To understand something, these are all we should keep in mind. Here, one theorem is there that is called current dividing theorem. Suppose it is given like this. It is given like this. V, voltage is not given, but total current is given, 4.16. Here, 3 ohm is given. Here, 2 ohm is given. What is the current through 3 ohm? Suppose they are asking. Total current is given, 4.16 ampere is given. What is current through 3 ohm? Current through 3 ohm equal to I3, I can call. Why I am calling I3? 3 ohm, that's why I am naming it as I3. I3 equal to total current 4.16 multiplied by other branch resistance divided by sum of resistances. This is called current dividing theorem. Other branch resistance divided by sum of the resistances. What is that? I3, how much current? Check. It must be 1.6. 1.6. Huh? Got 1.6? Yes. Check. Check and tell. 1.6 ampere. So what is the formula? Total current multiplied by other branch resistance, not opposite. Other branch resistance divided by sum of resistances. If it is a parallel circuit, to find current in one branch means other branch resistance divided by sum of resistances. It is, if it is 2 resistances, then only it is applicable. Find the current through 1 ohm. Find the current through 1 ohm. What is the nature of circuit? Neither series nor parallel. Combination of both. So how to solve this? Solve yourself. Find the current through 1 ohm. We have to find the equivalent resistance first. Once you get the equivalent resistance, you can find overall total current. Once you get total current, you can find the current through 1 ohm. So find the equivalent resistance first. Find the equivalent resistance. Equivalent resistance. While finding equivalent resistance, where we have to start? Always, if you start at correct point, then only you will get. You can proceed. Always, you should start from the tail. Where this is single source circuit. That's why we can simplify this and we can solve. Suppose there are 2 sources, means we cannot apply. We cannot apply this. We have to apply some theorem or Kirchhoff's voltage law or nodal equation. You have to write and you have to find it. But here single source, that's why we can reduce into single equivalent resistance and we can find the current. This circuit consists of only one source. That's why we can find equivalent resistance and solve. Where to start equivalent resistance? We have to take the far away. This is source, means which is far away from source. This part is far away from the source. That's why these two are parallel or series? How to find whether it is parallel or series? Total current is coming here. Here the total current is coming here and is divided into two parts. Current is divided. It means what? Current is divided means what? Current divided means parallel. So we have to think like that. So total current is divided into two parts. That's why it is parallel. Therefore, 1 ohm and 2 ohm are in parallel. Find the equivalent resistance. Yes. What are you saying is correct. 5 volt, 3 ohm. The parallel combination of this is 1/2 plus 1/1 equal to, then for that answer you have to find X inverse. You will get 0.67 ohm. The equivalent resistance is, now these two are in series. We found parallel combination of these two, that is equal to 0.67 ohm. So we put that. So this is equivalent to 3.67 ohm, 5 volt. Therefore, what is the total current? I equal to 5 divided by 3.67 equal to how much? 1.36 amperes. 1.36 here also 1.36 amperes. Therefore, current through 3 ohm is asked means 1.36 amperes. But the current asked is in 1 ohm. That's why we have to go further. This circuit. Here, what is the current through this? 1.36 amperes. Here it is entering 1.36 amperes. We know one theorem. What is that? Current dividing theorem. So we have to find 1 ohm. Therefore, other branch resistance divided by sum of resistance. For parallel circuit, if you want to find current in the one branch means we have to use the current dividing theorem. Therefore, I1, why I am calling this I1? Current through this is I1. Current through this is I2. Current through total current is I or I3 you can call. I1 equal to what? Total current is how much? 1.36 multiplied by other branch resistance. What is that other branch? 2 ohm. Sum of these two resistances, 2 plus 1, 3. 0.906 amperes. I1 equal to 0.906. This is one way of solving. Suppose I am modifying this. I am modifying this circuit like this. Is it possible to solve this way? No, because two sources are there. Either we can go for superposition theorem or we can go for KVL or KCL. We can apply and we can solve. We cannot solve this in this way. By equivalent resistance method, we cannot solve. When we can solve equivalent resistance method? If only one source is there, we can solve. I understand this. Otherwise, we have to apply some theorem or KCL or KVL. We have to apply and find. We are not going to solve this sum. What are the other methods? By using that method, how to solve this sum? That we will see now. Now, we will apply the same sum. We are going to solve by another method. 5 volt, 3 ohm, 2 ohm, here 1 ohm. 1 ohm. So I want to solve by KVL, Kirchhoff's Voltage Law. For that, I want to assume currents. You can put any direction as you wish. You can put any direction, but we have to start from the source. Any branch, but initially you start from source. Let us assume that current through this is I1. I am assuming current through this is I1. Let us assume that the total current I1 is divided into two parts. Let us assume that current through this is I2. Therefore, what is current through 2 ohm? I1 minus I2, because the total current, some part is going as I2, the remaining part is I1 minus I2. I1 minus I2. That's all. We have to check in this branch what is the current. In this branch what is the current? Here what is the current? Definitely I1. You have to check whether it is correct or not. What is current entering here? I1 minus I2. What is entering here? I2. If you add, you will get I1. You have to check. This is simple circuit. But in some complex circuit, you have to check. Some 3-4 branches are coming, means you have to add and check whether we are getting I1 or not. If you are getting I1, you marked correctly. Yes, we are getting I1. That's why what we marked is correct. It is simple sum. That is different. But anyhow, finally, you have to check finally whether you got I1 or not. To check whether we marked correctly or not. Now, I want to apply KVL, Kirchhoff's Voltage Law, to find current through 1 ohm. Because the question is, find current through 1 ohm. For that, I am going to use KVL, Kirchhoff's Voltage Law. Kirchhoff's Voltage Law says what? Algebraic sum of potential drop and EMF equal to 0. This is EMF. 5 volt is EMF. If you travel, I am going to travel like this: A, B, C, D. Like that, I am going to travel. First, I am going to travel from D to A along the current direction. Am I correct or not? Yeah, every branch you have to note the current direction. What we mentioned, this current direction need not be same. Actual current direction may be in the reverse direction. You need not bother. But you have to assume the direction is from D to A. We are traveling along the current direction. We are traveling along the current direction. So from D to A, we are traveling. You are traveling from 0 to 5 volt. Am I correct or not? This terminal is 0 volt, that terminal is 5 volt. Therefore, you are traveling from 0 to 5 volt. If you travel from D to A, you are traveling from 0 volt to 5 volt. There is a rise in potential. Am I correct or not? That's why plus 5. Why I am putting plus 5? While traveling from D to A, I am considering the loop D, A, B, C, D. I am considering the loop D, A, B, C, D. I am starting from D. If I travel from D to A, there is a rise in potential, positive, increase in potential. That's why I put plus 5. You are traveling from A to B. What will happen? Current direction is from A to B. There will be a fall in potential. Am I correct or not? This 5 volt will be reduced because of resistance. There is a fall in potential. That's why minus. What is the drop across 3 ohm? 3 I1. So why I am putting minus? Because fall in potential. That's why 3 I1. I am traveling now B to C. I am traveling from B to C. What is the current direction? B to C. That's why again fall in potential. That's why again minus. Minus 2 times I1 minus I2. Any other resistance or source? Nothing. So equal to 0. That is KVL. I applied KVL. Simplify that circuit. If you simplify that, what you will get? 3 minus 3 I1. Simplify. Minus 2 I1 plus 2 I2 plus 5 equal to 0. Or we can say that minus 5 I1 plus 2 I2 equal to minus 5. Or 5 I1 minus 2 I2 equal to plus 5. Let it be first equation. Am I correct or not? This is to understand. That's all. Review of your BW. Now we have to write the equation for second loop. In that second loop, I am marking this as E. This is F. So I am going to consider the loop CBEFC. Consider the loop. CBEFC. First, where I have to start from C. I am traveling against current direction. I am traveling against current direction. What will happen? There will be a rise in potential or fall in potential? Rise in potential. That's why plus. Plus, sir, here you put minus, here you are putting plus means what way we are traveling. Suppose I am writing BCFEB. Suppose I am writing equation. Listen this, then you can write. Suppose I am writing equation for BCFEB means you are traveling along current direction. Put minus sign. That's all. Here, while coming to 1 ohm, here you are traveling against current direction, you will get plus. So, whatever the loop you are considering, accordingly you have to write. You will get correct sign. So, CBEFC. I am traveling from C to B. I am not considering this. I am not considering this. I am considering this loop CBEFC. CB, I am traveling against current direction. That's why plus 2 times I1 minus I2. 2 times I1 minus I2. Traveling B to E, no element. No problem. From E to F, you are traveling along current direction. E to F. In 1 ohm, you are traveling along current direction. That's why minus sign. Minus 1 times I1. 1 times I2. No element in FC. That's why equal to 0. That's all. Sorry. Equal to 0. No EMF. Only drop only. That's all. Now simplify this. 2I1 minus 2I2 minus I2 equal to 0, or 2I1 minus 3I2 equal to 0. Let it be second equation. Solve these 2 equations for I2. Directly you will get answer. Ignore class test, that will reflect in the internal mark. That will reflect in the final result. So instead of concentrating on final examination, you concentrate on class test to get good marks, so that easily you can get 26, so that you can easily clear the subject. Okay, what is that answer? I2 equal to 0.909 amperes. So I2 is current through 1 ohm. I2 is current through 1 ohm. This way also we can find. This is called by using KVL, Kirchhoff's Voltage Law. Another method, loop current method. The same can be solved by using loop current method. 5 volt, 3 ohm, 2 ohm, 1 ohm. Loop current means this is called loop. Loop means closed path. Loop is nothing but closed path. This is one loop. This loop can be called as I1 loop. A closed path, any closed path is called a loop. Loop 1. This is loop 2. That's why it can be current through loop 2 is I2. Now we have to write to the equations. So how we can write? The same way we can write. For KVL, how you wrote? What is, you are traveling from A, B, C, D, A. For that, here rise in potential, plus 5. Then there is a fall in potential, plus 5, minus 3I1. Here again, we are traveling along current direction. This direction is I1. This direction is I2. Therefore, I1 minus I2. And we are traveling along I1 direction. Therefore, I1 is positive. I2 is negative. I1 minus I2. Why I am considering while traveling from B to C, I1 minus I2? I1 is positive. That's why I1 minus I2. Why minus? We are traveling along current direction. Minus 2 times I1 minus I2 equal to 0. That's the same equation you will get. Another one is For second loop, if you write EF, if you travel from B to F, no element, E to F, I2 is there, minus I2. Hey, don't talk. Minus I2, minus, here you are traveling around I2, therefore I2 minus I1. I2 minus I1, again we are traveling along current direction, that's why minus, why minus? You are traveling along I2. Why I2 minus I1? Because now we are considering I2. I2 minus I1 equal to 0. So if you solve, you will get the same equation. The same KVL equation you will get this way also. Another way is there. Another way is there. That is called Maxwell's equation. R11, R12, R21, R22, I1, I2 equal to V1, V2. Here, R11 means the first loop. What are the elements in the first loop? R11 equal to 3 plus 2 equal to 5. 3 plus 2 equal to 5. Therefore, R11 equal to 5. What is R12? It should be common to both first loop and second loop. The suffix 12 you should consider. It should be common to both first loop and second loop. Which resistance is common to both the first loop and second loop? 2. Therefore, R12 equal to 2. But we have to consider the direction of currents. I1 and I2 are in opposite direction. That's why minus. The rule is like that. If both currents are same direction, plus. So minus 2. Then R21. R21 equal to what? Common to second loop and first loop. The same element you will get minus 2. Why? 2 ohm is common to second loop and first loop. What is R22? R22 equal to what? 1 plus 2, 3. 1 plus 2 equal to 3. Now write that matrix form. If you write in the matrix form, what you will get? 5 minus 2, minus 2, 3, I1, I2, and here V1. V1 is voltage EMF in the first loop. If it is in the direction of I1 plus, if it is in the direction of I1, sorry, what is the direction of I1? From D to A, there is a rise in potential. The direction of I1, rise in potential, that's why plus 5. Here no EMF, that's why 0. Hey, check whether you got the same equation. 5I1 minus 2I2 equal to 5. We got the same equation. Second equation you check. Second equation 2I1 minus 2I1 plus 3I2 equal to 0. Sign can be changed. So you got the same equation. Therefore, if you solve this for I2 equal to 0.909 amperes. We got. Do you understand this? Suppose I want I2. This is 2 by 2 matrix, no problem. Suppose 4 by 4 matrix, 3 by 3 matrix. 3 by 3 matrix, not 4 by 4, 3 by 3 matrix. How to find I2? Suppose I want to find I1 also. I want I1 also. I1 equal to what? I1 equal to determinant of this matrix. I1 means first column replaced by right hand side. 5, 0, minus 2, 3. Whole divided by A, that is 5 minus 2 minus 2, 3. That is I1. Determinant of this. What is I2? I2 equal to, in the same way, you have to replace the second column. Second column replace 5 minus 2, 5, 0 divided by same 5 minus 2 minus 2, 3. That's all. Find I2. Check whether you got the same. Find the determinant. Find the determinant of numerator and denominator. Find it. Check whether you got the same answer or not. Power. So here, power equal to the product of V and I. P equal to product of V into I. The unit is watts. Unit is watts. Watt. Suppose they are asking, what is the power dissipated in EF? Find power dissipated in EF. How to find power dissipated? The same question, you have to find power dissipated in 1 ohm. You have to find. What is current through that? 0.909 amperes. That's what we found, But we do not know V. If you know the drop across 3 ohm, we can find it. That is 1.36 multiplied by 3. If you subtract from 5, you will get the drop across 3 ohm. The remaining parallel, so both has same voltage. So we can find. That way also we can find. So V we have to find. Therefore, to find V, voltage across 3 ohm equal to what? 1.36. Am I correct? 1.36 multiplied by 3. How much? 4.08. So V3 equal to 4.08 means V2 equal to V1 equal to what? 5 minus 4.08. That is equal to how much? 0.992. Okay. 0.92 volt. Now we can find the power dissipated in 1 ohm. P equal to 0.92 multiplied by 0.909. So many watts. How much? 0.896 watts. 836 watts. But we not find V, because this VI by Ohm's law we can modify this. We want to write instead of V, we want to write in terms of I. V equal to what? IR. So V equal to IR multiplied by I equal to I square R. Already we know resistance. We know current. That way also we can find. Check whether you got the same answer. 0.909 whole square multiplied by resistance is 1 ohm. Almost same answer, because here different values. That's why. Because you are truncating some values, But anyhow, 0.8 you will get. 0.8. What is the answer? 0.826, approximately equal. Because we are ignoring some higher values. That's why correct to 1 decimal place only you will get correct values. No problem. So you get the same answer. Suppose V means you replace I by I equal to what? V into I equal to, by Ohm's law, I equal to V by R. That is equal to V square divided by R. V also we know 0.92. Therefore, 0.92 whole square divided by R 1 ohm. How much? 0.8. 0.8. 846. Okay, 846. So because we are truncating the higher decimal places, that's why you are getting like this. Okay, but anyhow, 0.8 you will get correct value. If you write some 4 or 5 decimal places, you will get correct value, all equal values. Okay. But so power equal to what? VI or I square R or V square divided by R. I square R or V square divided by R. All the three can be used. It depends upon what value is available. What value is available. What is KVL? Algebraic sum of EMFs plus potential drops equal to 0. This way we can remember. Algebraic sum of EMFs plus potential drops equal to 0. What is KCL? Algebraic sum of currents in a junction. Algebraic sum of currents, all currents I equal to 0 at any junction. At any junction. So that's all. KVL is algebraic sum of EMF, all EMFs and potential difference in a loop. In a loop, that is important. In a loop. Kirchhoff. Five volt, 6 volt, 5 ohm, 6 ohm, 7 ohm. We'll solve by using both KVL as well as KCL. Let us assume that current through this path is I1. Current through this path is I2. Therefore, current through this path is I1 minus I2. Here, current entering here is I1 minus I2. Here, current entering is I2. If you add these two together, we got again I1. Now, let us take the loop A, B, C, D, A. Consider the loop A, B, C, D, A. For that, what is the loop equation? Write KVL. If you write KVL, we are traveling from A to B, raise in potential, that's why plus 5. We are traveling along current direction, there is a fall in potential. When we travel from B to C, that's why minus, fall in potential, minus 6 I2. Along CD, no elements. From DA, again we are traveling along current direction, that's why minus I1 equal to 0, or 5 I1 plus 6 I2 equal to 5. This is first equation. If you write the equation for second loop, this is first loop, this is second loop. If you write the equation for second loop, if you travel along B, E, F, C, B, B, E, F, C, B. You can travel any path you can select. You can select B, C, F, E, B also you can select. So if you select the B, there is a raise in potential, that's why plus 6. There is a fall in potential in 7 ohm, that is minus 7 I1 minus I2. There is no element in FC, but CB there is a resistance 6 ohm, but we are traveling against current direction. That's why raise in potential 6 times I2 equal to 0. If you simplify this, minus 7 I1 plus 7 I2 plus 6 I2 equal to minus 6, or we can write this is equal to 7 I1 minus 13 I2 equal to 6. Am I correct or not? Let it be the second equation. Solve these two and find I2 is required. So first equation multiplied by 7. 35, this implies 35 I1 plus 42 I2 equal to 35. Second equation multiplied by 5. This implies 35 I1 that 65 minus 65 I2 equal to 30. We subtract third, this is third equation, this is fourth. Subtract 4 from 3, you will get these two getting cancelled. This becomes 107 I2 equal to 35 minus 30 equal to 5. Therefore, I2 equal to 5 divided by 107 equal to how much? 0.046 amperes. So we got. Let us solve this sum by using KCL. Before doing that, let us solve this by Millman's theorem. loop equations. Let us solve this by using 5 ohm, 6 ohm, 7 ohm, 6 volt, 5 volt. This is current is I1. This is I2. Therefore, R11 is sum of elements in the first loop. That is 6 plus 5 equal to 11. And common to first loop and second loop is the second element, R12. First and second, minus 6. Why minus 6? Because I1 is this way, I2 is this way. That's why minus. Again, here also minus, common to second loop and first loop. The elements in second loop is 13. Therefore, I1, I2 equal to, what is V1 is? We have to check while traveling along current direction, is there any increase in voltage? Yes, there is an increase in voltage. That's why plus 5. Here also there is, if you travel along current direction, there is an increase in voltage. That's why plus 6. This is very important. Simply we cannot put 5 and 6. We have to check whether it is along the current direction. So 5, 6. Therefore, I2 equal to what? I1 equal to what? We have to find both, because current through 6 ohm we have to find. Find current through 6 ohm. The question is I6 ohm equal to what? I2 we have to find. I didn't mention that. We have to find current through 6 ohm. Here also we have to find current through 6 ohm. That is I1 minus I2. Therefore, we have to find both. Here I6 ohm equal to what? I6 ohm equal to I1 minus I2. Here I6 ohm equal to simply I2. This is what on the day one student asked. That's why one more sum I am solving. I am leaving incomplete all sums. I thought of leaving incomplete, but hereafter I won't do, because you all get confusion. So I6 ohm equal to I2 in the first part. Why? We are assuming that current through 6 ohm equal to I2. In the second case, as rightly mentioned by some students there, who rightly mentioned, sir, I1 minus I2, who said? Yes. So I also didn't mention, he correctly mentioned I1 minus I2. Current through 6 ohm is I1 minus I2. Why? Because current through that path, both currents are going through that 6 ohm, I1 as well as I2. Therefore, 6 ohm equal to, current through 6 ohm equal to I1 minus I2. That's why we have to find both. I1 equal to determinant of this by replacing first column by right hand side. Therefore, 5, 6, minus 6 and 13 divided by determinant of A, that is 11, minus 6 and 13. Cramer's rule. By using that, you can find I1. I1 equal to, find I1. Point. Yes, 0.943. 0.943. I2 equal to what? I2 equal to, we have to replace the second column. 0.897. Yes. Replace the second column. What is that? So we have to write the first column as such, 11 and minus 6. Replace the second column by Cramer's rule. What you will get? 5, 6 divided by 11, determinant of 11 minus 6, 13. That is equal to 0.87. Therefore, I6 ohm equal to I6 ohm equal to I1 minus I2. That is the 0.943 minus 0.897 equal to how much? 0.046. 6. We got the same answer in both ways. These two are based on KVL, Kirchhoff's voltage law. One is by using KVL, another one is based on loop current method. Now let us solve this same sum by using Kirchhoff's current law, KCL. If you use KCL, 5 volt, 6 volt, 5 ohm, 6 ohm, 7 ohm. How many nodes are there? Actually, it is misnamed. Node means junction of two paths. Junction is the correct word. It's named. Anyhow, node means at least 3 junctions. As far as nodal equation is concerned, 3 paths has to meet. Here, 3 paths are meeting where and all? One at A, another one is at B. So let us call this as V, unknown voltage at A. Unknown voltage at A is VA. We can call it as VA. This voltage, unknown voltage at B is VB. We can take any one of these nodes as reference. We have to take any one of these nodes as reference. Let us call VB as node, V reference. So how many nodes left? Only one. If you assume V reference equal to 0, we can assume V reference equal to 0 volt. Let us assume what is that? We are taking that reference as 0. Now we have to find VA. If you know VA, that is nodal method. We can apply KVL, KCL, Kirchhoff's current law. If you know VA, we can find what is the current through this, what is current through this, what is current through this, we can find. So what is current through 5 ohm? That is I5. What is current through 6 ohm is I6. Current through 7 ohm is I7. So we have to find all these 3. I5 is entering the junction VA. I5 is entering the junction VA. I6 is leaving the junction VA. I7 is leaving the junction VA. Am I correct or not? Okay. So if the current entering the junction means positive, the current is leaving means negative. So if we spend something, negative. If we get something, positive. So in the same way, junction gets something, that's why positive. Junction loses something, that's why negative. So if you assume what is the current through what is the current through 5 ohm? So we can write this way: algebraic sum of I5 plus I6 plus I7 equal to 0. So R, I can say that I5 is coming, that's why plus I5 minus I6 minus I7 equal to 0. Algebraic sum of, am I correct or not? I5 is entering, I6 is leaving, I7 also leaving. That's why I wrote KCL, Kirchhoff's current law I wrote. Now I have to find I5. What is I5? I5 equal to what? If we want current through 5 ohm, we have to find the voltage across 5 ohm. This circuit is identical to, if I put another way, you will tell. What I am going to do is, just to understand, I am modifying this circuit this way. Both are same. Both are same. You can put the element in that branch anywhere. Same effect. Anywhere. But current should not change. Current should not change. If you put here, here or here, current is same I1. Sorry, current is same I5. Now you can tell What is the voltage across 5 ohm? This is 5 volt. This is 6 volt. What is the voltage? What is the current through 5 ohm? Here, what is the voltage? Here, V reference. V reference equal to 0. What is voltage across 5 ohm? What is the direction of current? What is the direction of current here? What is the direction of current in 7 ohm? These are the directions. Am I correct or not? Can you tell what is the current in 5 ohm? A second figure. Refer second figure. Huh? 1 ampere. What is the current through a single element? We have to consider both ends. One end, what is the voltage? 5 volt. Another end, what is the voltage? VA. This end, that is the problem. This end, here 0, here 0, here 5 volt. Am I correct or not? Voltage across 5 ohm is 5 minus VA. Am I correct or not? From second figure, you are understanding. But in the first figure also same 5 minus VA. First figure, the resistance can be anywhere. Mentally, you have to assume that if two sources are there, you have to assume that the resistances are in between these two. Mentally, you have to assume. You understand this? This is very important while writing KCL. So you have to mentally assume that it is between two voltages. If you assume that, you will get. So 5 minus VA. Therefore, I5 equal to 5 minus VA divided by 5. 5 volt minus VA. Because this is reference, that's why this is 5 volt. Here VA. Current is this direction. That's why 5 is greater than VA. Why am I writing not VA minus 5? Why I didn't write? Because current direction is from 5 volt to VA. Therefore, 5 is higher. That's why 5 minus VA divided by 5. I6 equal to what? What is the VA equal to? We do not know. That's why VA, other end is 0. VA minus 0. Because we are assuming that V reference equal to 0. Therefore, VA divided by 6. What is I7? What is the current direction? VA to reference. So VA is higher. That's why definitely VA. VA minus. Here you consider. If it is in the other way, VA minus 6 is correct. But it is inverted. It is inverted. You are digging a well means you are in the first floor. There is no well. The depth is 10 feet. If you are in the first floor means. But in the ground, you digged a well, another 10 feet. What is the depth? 20 feet. Here, you connected in the reverse. That's why here, the voltage already minus 6. Am I correct or not? Here 0. Here it is in the reference. Here it is minus 6. Am I correct or not? Plus 6 or minus 6. If you travel from the reference, minus 6. So, what you are doing is correct. VA minus of minus 6. Minus of minus 6. Therefore, VA plus 6 divided by 7. VA plus 6 divided by 7. Substitute in this first equation. Substitute in the first equation. What you will get? 5 minus VA divided by 5 minus. Why minus? Current is leaving from the junction. Current is leaving from the junction. What you got? VA divided by 6. Again minus. Current is leaving from the junction in 7 ohm resistance. That is VA plus 6. VA plus 6 divided by 7. This minus sign. Current is leaving. Current is leaving. Current is leaving. Here current is entering. Why plus? Current is entering. Entering the junction. E equal to 0. Algebraic sum of total current equal to 0. Now we can write 5 by 5 minus VA by 5 minus VA by 6 minus VA by 7 minus 6 by 7 equal to 0. So we have to group all VAs. What you will get? VA minus 1 by 5 minus 1 by 6 minus 1 by 7 equal to 6 by 7 minus 1. Or you can write 210 42 minus 35 minus 30 VA equal to 7 minus 6 minus 1 by 7. So minus sign getting cancelled. 110, am I correct? 101. 107, yes. 107. Therefore, VA equal to 1 by 7 multiplied by 210 divided by 107 equal to how much? 0. 0.3 sorry 28, no? VA equal to 0.28, am I correct? VA equal to 0.28 volts. Therefore, I6 equal to what? VA divided by 6. Therefore, 0.28 divided by 6 equal to, that is the answer, you know, earlier. Here also that 0.047, am I? Okay. Okay. That is equal to 0.047. Here also 0.047 or 46 amperes. So we got in both ways we got the same current.